I want to thank everybody for coming. This is super exciting for me. I'm going to start by saying I came up with a mathematical structure that is kind of fun, and I want to present kind of just like some of the ideas surrounding it. And let's get started. So, presented by me. I'm Ajax. Okay, what is Aethic reasoning? So, okay, I'm debating about whether I should start with the double slit experiment. Anybody here heard of the double slit experiment? Yeah, it's weird, right? You turn the camera on, and the pattern changes. So it literally, even the semblance of maybe observing changes stuff. So this is kind of just a reasoning system that is like encodes what's happening there. That's basically the pitch. And then also it has some interesting results. So yeah, the fair warning, this is going to get characteristically weird. How I like it, because but you know this is where Steph is going to go. So yeah, this is some of our sections. I mean, you know, I could go over these, but this is the parts of the mathematical structure, and then you get to the end. And I'm going to try to zip through this. It's like 50 slides. Is it 50? I don't remember if it was 50 or 30. I should probably know that. It was 30.
It was 30.
It was 30. Well, that's a good number. So then we'll do that then. So here's the mathematical structure. This is like the big hump at the beginning, but it's also super fun. So imagine you have something like this kind of picture right here, where you have a system. You have part of a system. So for example, we've listed a simple system of circle, triangle, and square of different colors, right? Whatever. So here we're saying, you know, we're listing the properties of this system. Okay, that's what we might know of as a you know, the properties of the system as a set or whatever. And ethos is the new concept that came. It's a new structure. The idea is it's an equivalence class of all of the lists which derive each other. So if two lists derive each other, they're in the same equivalence class. So for example, like to give a really basic example, we might just say these two properties and them together, and then keep this property at the bottom. So now, even though you have a different list, it talks to the same description, because this list derives this list, and this list derives this list. So they're in the same ethos, they're in the same equivalence class. And another one, you can even get really crazy, and you can do like the exclusive or, you know, like all this fancy symbolic logic stuff, and this derives this derives this, or they're in the same equivalence class. That's an ethos. It's kind of the you know, the derivational heart of all of this stuff. And yeah, you know, and you have some of the vocab right there. And yeah, so the idea is, if we have a set, a single list of properties, we're saying it's kind of missing something. It's like missing part of the picture. Obviously, it tells you about the system, but it's not like, the implication almost doesn't go the other way in that it's only one rendition of the system. So the ethos is basically a take for how to like ideally get closer to the actual, you know, abstract ideal that is the system itself, because you can, every possible list, and through those lists you have all the attributes. So show of hands, like everybody gets that, like, right? Yeah, that seems pretty straightforward. If not, like, is it basically any questions about this? Yeah, hopefully it makes sense, right? Yeah, it's pretty straightforward. Okay, we're good. Everybody's good. So now we're going to get into some more of the fun stuff. Yeah. So okay, then you could talk about the lists are mappings. So in the previous slide, what we would imagine is all of these states we're actually setting, or these attributes, I should say, we're setting them all to true. So you set all of it, it's like a computer science kind of mindset. You set them to true, that's just what happens when you list them. But if you want to be a little bit more dynamic with what you can express, you say, okay, the statements are set to true, and then that way you can also put in statements that are false. So rather than having to say B is a triangle, you can say B is not a triangle and set that to false. So this is basic, and then you can even set something to a like a mathematical object. You can map to that. And then this is your list, and then what do you say? So this would also be an example of something that derives your original list and gets derived back from it. So these go hand in hand. You get one way and the other way. So but yeah. Anyways, okay. So this might be. Hopefully, this is looking pretty simple. I'm trying to get a read for like everybody. Yeah. Okay. It's gonna get. I know this is the simple part, but it's gonna get interesting. Okay. Now we're talking about blanks. Okay. Good. So what happens if you set something to blank? For example, we never talked about D so far. What if there was another shape, right? Well, we would notice that in our in our previous stuff, there's no mention of it. So we're assuming here that would be equivalent to mentioning it, but setting it to blank. So it's just like adding a zero, not adding, but concatenating a zero at the front of a number. Like for example, let's say I do 10 versus 0, 10 in base 10, right? These are equivalent numbers. So that's basically the same idea. If you append a blank attribute, you're left with the same ethos. So that's another example. And now this is where we get to the fun part, which is, which is, now we're going to say something called Aethic retrieval, which is you go to your ethos object and you retrieve the attribute you want. So rather than just indexing the state, like let's say we say, what is A? We request from this ethos, what is A? Well, you would say A is a circle. Or for example, maybe we request, is A a circle? That's a better example. Is A a circle? It's going to give you true. So rather than directly accessing the things directly in here, the idea is every time you want to use something underneath this, you're going to take it from a retrieval. You're going to put a retrieval on it, take the thing out, and that's how you do it. So what shape is D? Blank, which in the case of blank, that's where you have the second option here, which is you retrieve all the possible states. So what shape is D? If you retrieved what shape is D, it's going to give you the set of all possible shapes because it's blank. Yes?
Could I retrieve what shape is E?
You could, and it's blank. It's perfect. You're thinking exactly right. E isn't mentioned here, but you can still retrieve it. We're assuming it's blank if it's not mentioned and it's not derivable. So you'd say, what shape is E? Blank. It would give you the set of all shapes. And then you really want to get into the, I'm not going to get into the weeds yet. Okay, so I was going to, but I'm not going to. I thought better. But yeah, and then Aethic dichotomy theorem is, I guess I'll just mention it. It's like, what if part of it, what if I say, what shape is the tuple of CD? And it's just a combination of two attributes. That might be confusing, but the idea is you can layer attributes into a new attribute because it's just an attribute, it's just a layered attribute. It holds many attributes. If part of it is stated, the other part is blank, it retrieves the set of all states that attribute can hold, that the combined attribute can hold, where the one that's stated is stated and the other one's allowed to vary. So here's the normal distribution example. Right? If we say in this ethos, the normal distribution, right? We had that top picture where the mean is fixed and the standard deviation is fixed. We retrieve, and from this is the ethos, we retrieve, give me that normal distribution. It'll give you that. Now, if we allow the mean to be blank, and the other one, the standard deviation is blank too, it'll give you all the possible normal distributions. And then if we only fix the standard deviation, but keep the mean blank, then it will give you the set of all possible shifted normal distributions. So this is basically the structure for how we're setting this up. And then, so then the kind of quantum application here is we're saying, okay, well, if you have a system like this, like everybody knows Schrodinger's cat, yeah, everybody knows, right? Then the basic idea is we're saying, okay, you could encode this with an ethos by saying Schrodinger's cat is alive, blank. And then that would give you the set of all outcomes. So again, we're not making any kind of like philosophical assertion here just yet. We're just saying that would give you the base rundown, which is Schrodinger's cat's in the box, true, so we know that much. That's fixed. Because if this was blank too, then that would also return everything. Yeah.
Is there a reason for the asterisk for blank?
That's a good. There isn't any. I just I put it in there just in case. Like, what if there was like a shape called blank or like a color called blank? You know what I mean? So I just did that just for like a touch to be like, no, this is the blank, which is also like that's a great question too. Like, even in the abstract sense, every blank equals every other blank. It's just one thing that you're using over and over again. But it's like it's its own special thing that has this property. And then basically, so the gist of the idea with the ethos is you're trying to construct an ethos using blanks, using not blanks, and then everything you wanted to give you all possible options, you encode that in as blank. You don't encode it in as everything. So it's different than a contradiction. Because we say, well, Schrodinger's cat's a contradiction. It's alive and dead. That doesn't make sense. So the pitch here is, but you could describe it if you use a system like this. It would make intuitive sense because it's not a contradiction, it's a blank. It's encoded as a blank. And then, yeah, does that make sense? So this is like the first pitch. I'm actually going through this surprisingly quickly, so if this is good. Everybody, like this might be really simple so far. If so, great. But yeah, I don't know. We did that. Okay, that's the other super important concept here, which is we're going to allow. Yes, yeah. You first, yeah.
So this is maybe I don't know, maybe I'm going the wrong way, but
Sure.
I think an implication of that example
Yeah.
would be that you could just have like this list of attributes and you just have the first one. So then it's a cat that
Yeah.
has no life characteristic.
Yeah. Yeah. So what if you made this one blank?
No, if you just remove the second one, because that would still.
Oh,
be the
you
same
removed the second.
Yeah.
Well, the thing I'm thinking though is I see. Yeah. If you removed it, it wouldn't make a difference because
Right.
it's already blank.
But
Oh.
the cat just wouldn't have like no live or dead.
Oh yeah, right. But it wouldn't be that it's none is the fascinating thing. It would be that it's both, according to this framework. So basically, both is just what blank becomes. So that's how a contradiction is different than a both, if that makes sense. So like that's the key takeaway from this, among other things. It's like, oh yeah, a superposition of two things at the same time in quantum doesn't have to be a contradiction. It can be a blank. They can be different. They can be on opposite sides. As you add into a blank, and you get a state. So that's like going in the additive direction. But if you remove from the ethos, you go in the other direction, that's a superposition direction. So backwards is superposition, forwards is contradiction, if that makes sense. So they're actually kind of polar opposites in that way. So yeah, invalid ether. Okay. So yeah, and that's just what I just said. Yeah, so contradictions, there's a difference. They tell you different. Invalid. Okay, no, this is a little different too. Invalid ethi, you're also asserting that certain ethi can. That's the plural, by the way, of ethos. You're asserting that some of them can be invalid. Okay, so some of them just don't work. For example, let's say we make an ethos where we say 1 equals 0. Now this is one of our attributes. We'll say attribute, right? If you put this in your ethos, that's a contradiction. And we know that by the rules of logic. So contradictions still hold in an ethos, except they hold when you specifically put two things in an ethos that clash, that conflict. So for example, I'll give you a classic example of a contradiction. One attribute, everybody can see this, right? We're going to say x equals 1, and we're going to also say x equals 0. And we're going to put these in as two attributes. This is a classic example of a contradictory ethos. So that wouldn't work. That would be a contradiction. However, if we said x equals blank, and then maybe somewhere else you say x has to be a number, now when you retrieve x, you're going to get the set of all numbers, right? Or the set of all whatever the condition was, which again is that dichotomy theorem thing, which is you fix some, you don't fix some, depending on what your structure is. So yeah, am I losing anybody? This is all okay. Everybody's still here. Okay, good. I'm periodically checking, and I just want to make sure. Yes.
So in that example, it was sort of implicit that some sort of set of numbers was like the base set out of which you were building your ethos, right?
Yeah, right. So that would be, you put that in as an attribute. Everything in your ethos you want to be fixed. So yeah, for example, I could say that's a great point too. Because which set of number? What did we mean by number? I could say rational number. X is a rational number. Retrieve x. Okay, there's no state in there that says what is x, so that would be blank by default. So you say retrieve x, it gives you the set of all rational numbers, or a real number, a complex number, blah 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 blah. Whatever you want, you get to tailor your ethos to what you're looking for, and so yeah. And then this is just saying an invalid ethos, a contradiction's a classic example, where that's the generalization to the ethos. Yeah, yep.
So if it's invalid, is it not an ethos, or is it just?
Yes.
Okay.
Great question. Great question, Three. Good job. Yeah, you're really getting this. So yeah, it is still an ethos, but it's a special class of ethos called an invalid ethos, which is, again, it's a generalization of a contradiction. For example, a contradictory logical statement is still a logical statement, it's just a contradictory one. So, but the key here is we're also going to layer in more methods of making an ethos invalid. Contradiction is a class of one, but there's going to be more methods. And the art of this approach altogether is going to be to layer in whichever methods give you the results you want. So I'll get more into that in a minute. But so that's the, and then I don't know if you've ever heard of Plato versus Protagoras. I don't know if you've ever taken that kind of philosophy class. It's like a deep thing, but the idea there is it allows you to build a contradiction. It allows you to not build a contradiction in the structure itself, but that's irrelevant for this. Okay, ontology. Anybody know the word ontology? It's a philosophy word. You do, yeah. It means, right? Yeah, you've taken a lot of philosophy. Yeah. So it means the real world. It's like you got the mathematical component of something and you got the ontological. It tells you about the real world, what's really happening, how things are operating. So it's like bring it to reality is basically what it means. And now we're going to talk about an ontology. So this is where we get into the real philosophical. So buckle up for this part. Have you ever wondered, like, where's possibility stored? Think about possibility of what could happen in the universe. Where's it stored? And then, right, we have the classic answer. The future timelines would haven't yet branched. So the timelines haven't branched yet. That's where the possibilities are stored. And this is kind of like how I intuitively grasped it originally, which I think is like the default answer. Like, okay, we're not gonna, like, tomorrow could look like this, tomorrow could look like this, and it's the future is what like holds them apart until we get there. Like timeline splits, timeline branches, the classic thing. The Aethic answer is, now that we've developed this framework, why don't we entertain a funny idea, which is, what if the possibilities are just stored in the retrievals with the blanks? So everything that you don't know yet is a blank, which is kind of, this is where we get into the crazy stuff, which I mentioned at the beginning, because it's only going to get crazier from here. But the pitch, if you know, like the kind of the long-term pitch of this, is if we start to think this way, then we can actually start to model things with ethi. Whereas if we don't, then we're stuck here, and you know, you could use this method, but the second you flip down to this model of the universe, then you can start to entertain some of the Easter eggs that this will give you. Excuse me. Yeah. So that's the pitch at least. Okay. So Schrodinger's cat. This is how a classic wave function collapse looks like in quantum mechanics. You have a state, you have a superposition, which, right, you can kind of tell you're kind of uniformly combining them, linear combination. Anybody here taking linear algebra? Yeah, everybody, yeah. You're just combining them. And then you get the superposition. And then in the Copenhagen interpretation, which is the standard interpretation of quantum mechanics, you go here, you pick a single state out. So the pitch here is we're saying, okay, what if we assume that the Copenhagen is only ever taking the diagonal? Right? As in in Copenhagen, if you rewind time, you get back to the superposition. So basically what I'm saying is that time goes this way, but there's also like a this way component in the dimensional sense of the word. So if you go to the later time and then you rewind time, right, we basically get an entire new block universe, you could call it. Which is, okay, it's not that we're, okay, then you're like, wait, so you're going to a new universe. Not really, because that has like all of the baggage of like multiverse stuff. This is like a dimensional type thing. Kind of like how we know time is a dimension, so we're kind of constantly ticking forward with time. The idea here is like, okay, there's also like a second direction, which is, I don't know, it's speculative, yes.
So like, about like time and it being, like I feel like time is a lot more emergent than it is like, you know, like a separate thing. And if we think about it in terms of like when you're talking about how possibilities are stored in the retrievals of your ethers, like doesn't that collapse time to just being now? Like that collapses like this our causal interpretation of time of, you know, there being a now
there's like
and a
the
future. You know, like it reduces it to now, and like our that's our human limitation that we can only go through it step by step.
Oh, got it. So
but
it's,
like,
yeah.
you know, like if you abstract out of,
But it's just something we made up. Yeah.
Exactly. If you abstract out of this like individual timeline, then you can realize that like it's all now.
Yeah. All you feel is the now. So the question is there even, like, how do we even know this is a thing down here? Like before the now, the past, or up here, right? Yeah.
Kind of.
Yeah. Okay. We only know now. What we even understand about it, we have an approximation of what now is, and then we have before and after. So yeah, I probably should have led with this on that topic, but there's different philosophies. You got the Einsteinian philosophy, which is everything is lined up already, and you just happen to be going like that through it, but everything is lined up, right? Yes.
What is the one for red tube on the previous slide? On the previous slide?
Oh, yeah.
Where did that come from?
Which one?
The one over ran to.
Oh, the one over root 2?
Yeah.
Oh, yeah. That's you have to normalize in quantum mechanics. That's a great question. Yeah. You need this is a vector. Is the weird thing. You need the magnitude to always be 1. So, you know, if you just think unit circle, it's literally just rotated to the 45-degree mark. That's a great question, yeah. It's just like a standard quantum notation thing. But yeah, that's a great question. But yeah, you know, and also to just jump into this too, you know, so this is called presentism, which I think, Nishka, is what you were basically saying, is like, we only know of this. What even is this? All we can do is approximate what it is. Is that basically it? Or is
I'm
yeah.
basically saying that it's not just that we know this, it's just that it's all this.
Oh, that's all we have. Yeah.
Yeah, that's like our interpretation of things being causal is our limitation.
Yeah.
And it's not how it truly is.
That makes a ton of sense. Yeah, because even if you look at like thermodynamics or whatever.
Exactly.
It's like it's just stuff jumping around.
Exactly,
like what even is happening?
Combinatorial,
Yeah.
exactly.
Yeah. Good point. Yeah. So even this is like, yeah. So I should also mention actually the structure here, because now we really get into the philosophy. It's like, what is time? This is simultaneity. This is like Einstein's concept. So it's like almost like a sub-segment of time. It's not even the big picture, but it's like if you have 2 clocks and you make hit them at the same time, 2 stopwatches, that's simultaneity. And in Einstein's theory of relativity, you're going to notice that if somebody starts speeding up, right, to the person who wasn't sped up, you hit this clock and you hit this clock at the same time. Right? The person who's speeding up, this clock goes first before this one because they're hitting space-time from a different angle. Because all velocity is, according to Einstein, is you're rotating out of space and into time. This is like the geometry of it, which is wild. So, okay, now this is your point of view. So, like 2 clocks that are lined up, now you're hitting it from below. So one of them happened first, which is like the weird thing. So, yeah, obviously all the layers. Even what this whole idea of mine is, I'm trying to like, is there another layer? I'm trying to like get at the further layers. But the established physics layer is simultaneity, right? Like that, if that makes sense. So I like this illustration because it shows you're hitting the block from different cross sections. But Einstein's idea is the whole block has to be there because at any given moment somebody can have any cross section. So in order to say that part of the block doesn't exist would be invalidating that person's cross section, but you can't do that because they're there. And they could be there. So yeah. And then this idea, I'm trying to add another degree of freedom. Everybody know the term degree of freedom, right? I'm saying, okay, I should have gotten into this too. I can say this now. But yeah, the block universe is everything is stuck here. Everything is already in existence. Growing block universe is the only the time is evolved. This is like the intuitive one. It's like the future is still occurring, or is still coming into existence with the flow of the present. So my pitch is that this one right here contradicts Einstein's theory, because like I said, you can take any cross section and everybody should be equally valid. So this contradicts Einstein. This contradicts quantum because of something called Bell's theorem. I don't know if anybody heard. It was hit headlines a couple years ago. But yeah, this contradicts quantum. So our 2 big models, one of them contradicts relativity, the other contradicts quantum, which are the 2 big pillars of physics. So all I'm doing here is I'm saying, okay, you know what? We're in a false dichotomy kind of situation, meaning that's a logical fallacy when you only have 2 options, but you need a third. So I'm saying here's a third option. Here's a simple third option, which is there's another. You take an entire other block universe, and it's not that they're 2 distinct; they're attached. So it's like another dimension. You just like moving. It's like motion. So you have this extra component of motion, kind of like how we already have the time component of motion. And then as you go through that extra component, you get to a state where it's always been collapsed. So for example, the cat turns out to be alive, then in the past of your new coordinate, right, this is time, future, past. In the past of your new coordinate, the cat was always alive. But in the past of your old coordinate, and in the future of your old coordinate, all the way through, the cat's always in superposition. But you only ever follow into the collapse, right? So you think that these are the same block universe because you're going down the diagonal. So you're just simply not extrapolating that there is a new past and a new future. And again, that's wildly speculative, as we know, but the pitch, I'm trying to lead all of this through to making an assessment about the double slit experiment, which again, I'm taking notes here. I probably should have led with that a little bit, but I might even just jump to that. But yeah, well, you guys, as you said, you know what it is. It's weird, so I'm trying to like weirden up metaphysics a little bit. In other words, you know, how time works in order to like get there, so I can like describe it. So sometimes you have to drop something, and I'm dropping this notion of a fixed arrow of time. Yes?
How did we get from the ethos of the beginning to this?
Okay, yes. Is that even in here? That's this slide. Okay, thank you. So it all ties in. The ethos now, I'm saying, tells you which block universe you're in. It tells you your coordinate. The ethos is a coordinate. That's all it is. So you have time, and you have this extra time. The ethos is your coordinate in extra time. That's the pitch. That's how it ties in. And that's also when I said, where is possibility stored? It's stored in your ethic retrievals, because when you have your ethic coordinate, it tells you in your entire block universe, which is with you, it tells you what's in superposition, what's collapsed, what's fixed, what's superposition. So it's no branching, like, right? You get it? It's no branching like what's happening here. You have a block universe, but it's a new style of block universe from what exists before, because it's an ethicized block universe where, now you have, it holds a content of superpositions based on its defining ethic coordinate. That's the pitch. So, so reality is relative. Now, the weird thing about that is you say, okay, well, there's a bunch of block universes in a sequence, or more specifically along a dimension, continuous dimension. And, so which one's the real one? And we're saying just like in relativity, you say, okay, there's no objective simultaneity because one person is going to see the clocks at different times, the other is going to see them at the same time. Now we're saying there's no objective informational objectivity. There's no objective fixed state versus superposition state. So everybody, it can be in superposition or not, depending on which coordinate along the ethic dimension is, in other words, which ethos you're in. So that's where it all ties in, hopefully. First postulate of the ethos. Now we're going to make 3 axioms, aka postulates. This is our first one. I already told you about the second one, because that was the retrieval one, where blanks retrieve to everything. But the first is the ontological one. It's the real world, informational one, which is, yeah. I want to say real quick, I know this stuff is really wild and crazy, but again, that's the pitch. We're saying we have to sacrifice stuff, like Einstein did with simultaneity. When you get in a pickle, like what we're in with quantum mechanics right now, where people don't know really what happens when the superposition collapses, when you get in that kind of pickle, historically speaking, Newton did this, Einstein did this, Schrodinger did this, you got to just drop something. So I'm just saying, or sorry, not Schrodinger, Heisenberg did that. But yeah, so that's just something we're dropping, is objective reality. But it's not that there is no reality, it's that it depends on your coordinate. It's variant with your ethic coordinate. That was freaky, the light just dipped. All right, yeah, thank you, University ethic coordinate just, yeah. Okay, the union principle. Okay, this might be the trickiest part, and probably second trickiest part. But yeah, the idea here is we're actually going to search a structure. How am I even going to say this? Yeah, okay. Okay, so I'll say the pitch this way. When we talk about Schrodinger's cat, alive and dead, we say and, right? When we talk about, okay, this is on this table, if everybody can see, this is on this table, and this is on this table, we also say that's an and. So what I'm saying here is Schrodinger's cat should actually be an or, but of a different kind of or, because we know, as we showed, you get all possible states when you do the retrieval. So it is an and, you observe it as an and, but again, I gotta really make sure I'm hitting the point of this, because you'll get it, but it's subtle. So basically the idea is, as you're in your block universe, if something is unknown to you, then it's gonna be blank, and it's gonna retrieve as everything. Now, as you go forward along your block universes, as you learn more and more, you might, you can get this kind of and, where you say this is on the table and this is on the table. So I'm saying this is a standard classical and. But an or could be something like, oh, this is on the table or this is on the table, right? And you have one or the other. And basically what I'm saying here is you kind of have to picture two different, again, it's the same two different things. Yes, yeah.
Is this kind of like with the Schrodinger's cat thing?
Yeah.
Like until we look in the box, it's both.
Right.
But then once we look, it's an or.
It's similar, but it's more subtle. So basically the idea, okay, here's the question, here's the thing. The idea with the block universe is we're saying it's always and in the first, and it's always one or the other in the second. Not even or in the second, just one of them. And you'll have two possible second block universes, right? Because you'll branch, but branch Aethic-wise, not time-wise. And so the idea with this principle is you have an and like that. So I'll put it this way. I'll use two different things. You have an and like those two things are on the table. You also have things that are more or-like. I wish I came with a better example. Let's see if I have anything here. Something or something else. We're saying that's going to be the union operator. Because anybody here take probability or logic? And you know that unions are or, intersections are and. So the idea here is we're actually going to refer to the probability terms. But we're going to say that sometimes when we say and, we actually mean a union. Because of the misinterpretation of not even misinterpretation, because of the ambiguity of the blank things in the superpositions. So basically, so that's an and state, and then an or state would be something like, here's a good example. Okay, I got it. So I'm standing here, or I'm standing here. Right? Imagine that there's one of the two possibilities. In Aethic reasoning, we're saying if I don't know which one I'm at, then in that block universe I'm here, and the other block universe I'm there. And again, wild. But with this one, you actually have two different objects, right? So you can say that they're both. It's an and you don't get a contradiction. But with me, if I'm here and I'm over here, that would be a contradiction. So you have to set it to blank so you can leverage that part of not making a contradiction. So with this kind of attribute of where I'm standing, because I'm a single person, those styles of attributes, you have to say an or in order to get multiple outcomes. But with this kind of attribute, where there's two of them, you can say an and. So the idea here is that with Schrodinger's cat, let's pretend I'm Schrodinger's cat, except with position. So I'm here, or I'm here. It's alive or dead, but except for here. And you don't know, so you haven't looked in the box yet to see which one I'm in. And so the idea with that is I would be in both. I would truly be in both, because in your block universe, I would be in both because you haven't looked in the box yet. Again, weird, but this is part of the exercise of all this stuff. But so I am at both in your block universe, but I'm also not in an and state. I'm actually in a union state, because an intersection would give a contradiction. In other words, in the structure of the ethos, it's a blank where I am. It's not a both. It's not one is in the ethos and the other is in the ethos. It's a blank. So blanks are like unions. And this are in there together are like intersections. So even though it presents as an and, as in literally in your block universe, I'm here and I'm here, both are retrieved from the set, it still counts as a union. So a union can present as an and, as a physical and in your block universe, even though it's a logical union, which is more like an or. So in other words, all of the physical ors, every time we say or, all the physical ors become logical ors. They stay as ors logically, but physically they become ands. That's the pitch. even though logically they're ors. And then you talk about physical ands. Sometimes they become logical ors, like Schrodinger's cat, but sometimes they stay as physical and and then sometimes they stay as ands like that. So that would be a physical and a logical and. Sorry that took so long to unpack. Does that make any sense? That's very confusing, but also rigorous if you really think about it. Yeah.
So is the difference that those are two different attributes
Mhm.
that will
Yes.
not contradict each other?
Yes.
So we can just and them
You
together?
can and those two the heck together. We could even have one ethos where this is on the table, this is blank. This is on the table, this is blank. And then you're going to intersect those, and them together. Now you have, and yeah, no contradiction is
But
raised.
they'll never contradict, but you would
Yeah,
contradict.
yes. So they're different styles of attribute. Maybe because it's even a single attribute. But yeah, that's a great, sorry, I'm kind of like improvising how I'm gonna explain this as I go. But yeah, the pitch here is, yeah, that you're exactly getting it. Which is, because I have an attribute like this, where I'm here and here, intersecting doesn't do you any good. So we know you're looking at a union. You know you're looking at a blank. Blanks and right, unions give you blank. So if I have me here, that's one ethos. Me here, that's another ethos. If I union them, it turns blank. Because it disagrees. The attribute disagrees, so you pull it out of the ethos. If it disagrees. That's how you get an ethic union. So if then, I probably also should have explained that. In an ethic intersection, you just dump all the same attributes in. But to note, is different than set unions and intersections, but it's purposefully the same as probabilistic event intersections and unions. So me here, union me here, gives you the accurate probabilistic statement, which would be you would get both. But that's only because probabilistic events picture like adding up all events, where with the ethos we're actually doing it the other way, which is we're specifying in. Instead of counting up everything that's here, we're specifying in with intersections and then generalizing, broadening out with unions. But yeah, so the pitch here is that basically what we think of as and or has to go out the window and has to be replaced with intersections and unions, which are a little weird. But it's saying that ontologically everything we were doing was an inconsistency in the physical domain. In the logical domain, everything holds. But in the physical domain, some of our ands are ors, and some of our ors are ands. We have to restructure this in order to move forward. That's the pitch. Yes.
So it's just that the word and doesn't
hold.
it means two different things.
Yes. It means physical and logical. Yes.
Okay.
Physical, logical. That's a great way. But yeah, that's a great summary. Right. Means two different things. You have logical. You have an or and an and. Physically, you have an or and an and. Basically, yeah. I'll say this one more time. You take the physical ors and you move them all to logical ors, and you take the physical ands, and you take the physical ands, and some of them you were just wrong about, like Schrodinger's cat. They become logical ors, even though they stay as physical ands. So everybody stays as a physical and, because in your block universe they're physically and, even with me here and me here in the superposition, because it's blank, it's in physical and just because intuitively they're both in the block universe with you. So everything gets to be a physical and, but some of the physical ands flip to physical or to structural ors, mathematical or logical ors. That's what I said. Yeah. Okay. So this is now we get to do. That took a long time. Sorry. I'll try to work out how do I explain that better. But here we have an agreeing superposition versus a disagreeing. This is of retrieval objects this time. So an agreeing superposition is you take two objects and you take the union, or the logical disjunction. So this is operating over the logical domain, since the physical domain is always ands. So in the logical domain, you take two retrieval objects. So for example, I'm here versus I'm here. That's A and B. Maybe this is A, that's B. And then you union the retrievals, and then you get a physical and, which is I'm at both in your block universe, even though it's encoded in the ethos as a union, aka as a blank. So yeah. And then is that making sense? I'm like talking really fast here. Yeah, I know. That is the hard part. Yeah. It's a reworking. That's all it is. It's just a reworking. But yeah. But the idea is we want the union to be our new or, and we want the intersection to be our new and, which we inherit from probability events. Okay, so we're just going to express everything in this new language. We're just saying that there's a bit of a carryover about which intuitive ands and which intuitive ors go to the new, union intersection. So basically now I'm saying we can construct two forms of superposition. This is the elemental superposition, which we've been discussing, which is you make all of the things that differ in the two ethi blank. And then in this ethos, what you do is you're going to take one ethos and you're going to intersect it with this ethos being false. So everything in this ethos being wrong, or, logical complement. So you're going to say this ethos intersected with everything in here, not happening. And then instead you take this ethos and you intersect with everything in here, not happening. And then you take the elemental superposition of those two ethi. So what we've done here, this is the key. Like the reason I just gave you that complicated explanation is to get to this, which is we call both, in our society, we call both of these, we say, oh, A and B happen at the same time. I'm here versus I'm here in superposition. We're saying, okay, I'm in superposition of them both happening at once. But we would also say I'm in superposition of both of these happening at once. It just so happens that in this one, me being here automatically implies that I'm not here, and me being here automatically implies that I'm not here. And yet, even though that's the case, we're putting those two in superposition. So me being here, but I imply I'm not here. Me being here, but I imply I'm not here. And because we just created two directions, a union and intersection, now we can kind of play around with ideas like this, which is intuitively, it's a superposition. I'm here and I'm here. And in your physical block universe, I am indeed at both at the same time. But in the version of there's layers to it. That's the thing, there's layers. The me that's here is implying that I'm not over here, even though the me that's here is implying that I'm not over here. And because we have these two directions, intersection and union, you can stack them like this and still get a seemingly, in the English language, we would call these the same thing. And yet they're different in the actual structure. So the key is, what I'm saying is, quantum superpositions are one of these guys. But everyday macroscopic ores are one of these guys. That's where the difference arises. Which is to say that it's a superposition in your block universe is technically of the same kind, in that it holds one of these guys, and yet you can't get any interaction between the different states because this one's always blocking this one from touching it, and this one's always blocking this one from touching it. And yet they're still both in your block universe with you. So basically, the way to get around this is you have to lose the intuition of, you're placing things in a block universe. It's actually you're placing a ladder of stuff. And the ladder is the unions and intersections and how far it's iterated down. So even, when I put these here, I'm actually placing them in the block universe with ladders under them. Not real ladders. I mean mathematical inductive ladders where, for example, you can have, are they in the most elemental sense, both happening together and they can interfere? So when you have quantum particles interfering, that would be this case where they're actually affecting each other. They're actually interfering with one another. Whereas this one, they're both in the superposition, but one of them is blocking the other one from interacting with it. That's basically what it roots to. Let's see how much further I can get. You guys want to stop it here? By the way, if we could take maybe I'll take a time check. Just in case I lost anybody and everybody wants a refresh or anything. But because I want to make sure I'm not going too far in.
So
yeah.
It is it's 12:06 right now.
Okay, so we might. Yeah, that makes sense. It took. Sorry, everybody. Did I lose anybody? It was going a little bit too. Yeah. But yeah, it's a lot of stuff to take. But it's a lot of math. I'll tell you that much. But I got the footage. I got to explain to everybody. So I think that's definitely a good start. I just want to take a check of the room. Is everybody just knocked off their feet and they're like, okay, I need to let this sink in because it only gets worse. Yeah.
That second one seems like it's very quick to explain. I get that.
Right. Yeah. This is what we talked about with the retrievals, the blank. This is it stated again. But now it's also stated with the ontology, with the real world. Maybe I even should have put this slide first because it'd make the previous slide easier to understand because it's in the block universe. I don't know, whatever. And also you have that ladder, which is key because now you lose that Boolean state. Now you have full ladders of however many iterative combinations you want to make, uncountably infinite possibilities. It gets wild. So yeah, and again, that's where we're going to structure the Aethic version of superpositions it's a gold rush. In all of those new degrees of freedom, we're going to be able to structure some new stuff. I don't know. What am I saying here? Okay, child ethos. Child ethos is you take an ethos and you stick in a new attribute. So here, what shape is D is blank. Here we said it's a star. So that's a child ethos. Parent ethos is you go the other way. You pull out an attribute. That's just some vocab. I'm just going to try to see if I can go in. You put one in, and then also you can write it as it's the same thing as intersections and unions. So parent is you union, you pull attributes out. Intersection is you put more attributes in, you intersect. And again, the unions and the intersections match what we see in the real world, the retrievals, rather than actually the attributes. Because again, like unions, you might think, when you think of a set, you union the sets, you gain more attributes. But here, we're withdrawing attributes with a union, because we're broadening the possible retrievals you can get, because every time we put a new blank in, every time we replace something with a blank, we broaden our retrieval sets. Because of the second postulate, with the blanks go to everything. Yeah. So yeah, and again, like the intuition you want here is you want that ladder intuition, which is you're replacing a Boolean. You say, oh, this is here and here. It's uncharted territory, like two things happening at the same time. So like the first layer we're saying is, first of all, it's a blank in an ethos, which is different than just a contradiction. That's the first layer. And the second layer is we build that ladder, which is you can have two things happening at the same time with more ways than just two, or more ways with just one, I guess. It's not just this is here and this is here at the same time. It's the iterated layers of unions and intersections. Excuse me. And I also just want to say what probability is in ethic reasoning, which is, what if you take an attribute and you decide to only add it in by half? So you like put a coefficient of 0.5 on it, you would just get this. And then you put another one in and it gives you back this or something. But yeah, that's basically the idea of what probability is. Because if you're in this state and you want to retrieve that, obviously it's going to give you that superposition of possibilities, but it's also going to skew it towards star, because we like half moved it towards star, if that makes sense with the probability. But that's kind of unimportant anyways. I just wanted to stick that in here. Okay, now we get to the double slit experiment. Again, maybe I should have put this at the beginning for a kind of pitch, but yeah, this is what it looks like. And everybody knows a double slit experiment? Yeah, again, yeah, I asked that already. But yeah, so yeah, when you, I'll just skip through this, but when you flip on the, when both slits are open, you get a different thing than that. You stick a detector in. I'm not doing this any justice and explaining it well, but whatever. You stick a detector in, and the pattern goes to the overlay of the two ones of these, rather than like mimicking what it is there. Even though it's the same configuration, we're just putting in a camera, which is weird. And then when you turn the camera off, you get back to that, which is weird. So now we're going to start to map. We're going to describe this with Ethi. This is where we get in. This is what I said was going to be the hard part. This is where we get in the weeds. But again, I feel bad. Like if everybody's kind of getting stuck here, you want to do it? Okay. Yeah. Yeah. All right. Thanks. All right. Let's do it. So yeah, these are our cases. Okay. So the key we got to start with here is, in this case, we've set it to blank. We've set which slit has been gone through to blank. In this one, we've set it to this one we've set it to this one. And remember that agreeing versus disagreeing superposition thing? This is an agreeing superposition of the two slits. You're saying, because they allow one another to exist. If you put these into ethic superposition, remember these are two ethi, if you put these two ethi into superposition, where the particle goes through this slit and the particle goes through this slit, this is a disagreeing superposition. Because in this one, we have that this guy disallows that guy, and in this one disallows that guy. They disallow the particle from going through the other slit. And so it would be in this ethos that one slit disallows the other slit, and it would be in this ethos that one slit disallows the other slit. So when you take the ethic union, both of them have the slit disagrees with the other slit. Each slit disallows the other slit. So because you can't throw that out of your ethos, because it's in agreement with both cases that the slit disagrees with the other slit. So these two become a disagreeing superposition. It can't become just this, because you have that extra layer that there's that disagreement, which is consistent across both. So this is a different object. Again, this is really the meat of what we were saying with the ladder thing, which is this and this we would both think of as a kind of superposition in the block universe, in that they're both there. Right? In this case, they're both there. In this case, both slits are being gone through, and yet they're structurally different within the ethos. So then the pitch is this weird interference where the particles from one slit are behaving like waves with the other slit. That's what agreeing superpositions turn into. So this is this. And also with the case of maybe it gets deflected and doesn't get through the slits at all. So these two cases in ethic superposition, now we're doing a second order Aethic superposition, I should say too. This is a first order Aethic superposition because we're just taking it over attributes. Here we're taking Aethic superposition over ethi. So that's, again, like you're trying to iterate stuff out a little bit. And so yeah, that's also why I like the second postulate, because it gives you this iterative mindset. And then when you have these three, you take the union of them. Yeah, I'll see it. Thanks for coming, by the way. And am I at time, by the way?
You're at 55.
Okay, I'm close, so I should wrap it up. Yeah.
Just please finish this.
Okay, I'm
No,
going
yeah.
to.
Take your time.
Yeah, you think? Are you sure? Okay.
I'm gonna stay until you're done.
All right, thank you.
Yeah.
Yeah, and you guys can start to go out when you need to. Like, no pressure at all. All right, so Dorothy, thank you. So what we're gonna do is, yeah. So this is it. What I'm saying is now I'm taking this idea that the ladder thing gives you different states. The superposition of this is different than the superposition of this, and I'm turning that into a physical result, which is not only is this structurally different than this, but this is structurally equivalent to this output in the physical world, and this is structurally what gives you this output. So these are different structurally, and I'm translating that to the physical realization of those two being different. Okay, so now we get to step Z, step Y, step X. Why did I count down? Why didn't I go X, Y, Z? I went Z, Y, X because step X is not part of this presentation, it's part of my follow-up paper. So I wanted to sound badass, so I said, step X. Just because, like, that's the open question, just because, like, But we've already entered step Z, which is the second postulate, and the union principle, which is the ladder concept. Now we're going to enter step Y, and then that's when we'll finish out the presentation. And then step X is going to be a little more intense in, like, calculus, geometry, etc. So we're gonna save that for later. It's not part of this presentation. Don't worry. So yeah, okay. Now we're gonna try to figure out how we're gonna do step Y. How we're gonna solve step Y. And the don't is don't use mappings. I know it's tempting. I thought about it. Don't do it. Why? In other words, could we just say, oh, when you have this case, it maps to these ether. So when you want, in other words, you have one attribute, which is the detector on? So does detector on would be here, detector off would be here. Again, not even a blank. Detector on true, detector on false. So like the basic naive assumption, or approach, that's the word I'm looking for, might be, can we take detector on and map it to this series of cases, which matches the physical empiricism? Or can we take detector off and map it to these cases? The reason you don't want to use mappings is because it's inductively weak. Because the second you get another question, you'll be like, oh, I had only one mapping to use. So how do I make this mapping look like this mapping? And it becomes, so we're going to build that in. We're going to make it so you can take this mapping and apply it to anything. So it's not even that it is a mapping, it's just literally detector on will automatically give you these ethi, and detector off will give you these ethi, automatically, in this superposition. So how do we do it? All we have to do is have the new postulate we're going to make to do this. We're going to have it tell the system which ones to invalidate. It's that simple. That's like the clear method, which is, in this case, we're invalidating both of these, right? Detector off, we invalidate these instinctively, and detector on, we invalidate this. That's the pitch. And we're going to make a postulate that does it for us, okay? And we in other words, we're saying, right, when the detector is running, ethos P will occur, and we're turning an implication into, it's an invalid ethos for, A implies B, detector is running, gives you this, and we're gonna say it would be an invalid ethos for the detector running and this to happen anyways. So for this to happen anyways, which is the not B, because this is B, and this is not B, so, and A is detector on. So we're saying if the detector is on, then for this to happen anyways would be an invalid ethos. That's our in toward getting this postulate, as is the supposition. Okay, so naturally when this first came to me, I was like, okay, I'm gonna think of a thought experiment. Let's think of something fun that we can actually play out, right? Even if it's fictional or whatever, but as it would happen. So what we're saying is because I was saying the idea that like the superpositions in your block universe is just representative of what you don't know, then there should be some carryover to the macroscopic world, even if it's in the form of those disagreeing superpositions, which is one state disallows the other state to exist while it's happening, even though they're both still happening with the latter. So, yeah. So the idea here is, imagine we have Oliver, that's his name, I don't remember why I picked that name, but his name is Oliver, and he's with his friends in a soccer field. And actually, I thought of this, I was, I think, first week of freshman year, that's when I first thought of this. I was like, oh wait, yeah, and I looked out at the soccer field over by the freshman dorms, and that was the soccer field that I thought, I was like, oh yeah, I could play this out on this. So, just give some context, story behind where this came from. But yeah, I said, okay, so I have a blindfold on, and everybody gets texted a random door to go through, and then they go to a random number along the back wall based on the, random trajectory out from that door. And that is it's just a double slit experiment, but on the macro scale. So then I'm thinking, okay, if everybody did that, what pattern would they form? And we know obviously they're going to form the two piles pattern. Again, this is probably why I should have gone over the double slit experiment thing explicitly, but we know they're going to form this pattern because every macroscopic thing does. Macroscopic things don't act as waves, obviously. So then I asked myself, because of this thing here, where we're saying, if this did happen anyways, it would be invalid, then I also asked myself, well, if Ethis Q happened here, why would it be invalid? That's the intuitive, that's why you need this thought experiment to get you in the mindset, what exactly would go wrong? And then that's where you get your postulate, because that is the idea of what goes wrong, why it invalidates it. So, and then the issue with the extrusion principle, which if you might remember, is the one where you had the block universes stacked up like that. Is it retrocausality? Because you're stuck in one block universe, you don't know what's happening in the future block universe. So even if, okay, right. So then that's the beginning where it goes wrong. Okay, I'm figuring this out. So the idea is if you're standing here, and then everybody goes through the doors, and then you take the blindfold off, and then you see the interference pattern, the wave-like pattern here. Imagine if you go to somebody and you ask them, hey, which door did you go through? Just simple like that, right? In order for it to have the wave-like pattern, that implies they had to go through both doors as a postulate, or as a result of quantum mechanics, not a postulate. It's a result. Empirical result is making a wave-like pattern implies that each person went through both doors. So if you go to a person and say, hey, which door did you go through? Afterwards, they're going to say one of the doors, of course. They're going to say, oh, I went through door A, I went through door B. So that invalidates, the two invalidate is the idea. So what we're doing is we have almost guarantee that the future ethi, the child ethi, are going to have invalidities in them if you ask the right questions, and yet technically you haven't hit one of those contradictions in the moment. So the contradiction would be person goes through both doors versus the person goes through one door. They're telling you they went through one door, but what would you can assess would be right. Maybe you there's so many ways you could prove that. But the interference pattern, the wave-like pattern tells you they went through both doors. So that's a contradiction, but it's locked up in your future ethi. It's not in your present ethi. So then we almost get like a ambiguity because we're like, well, with the extrusion principle, we're saying that there's different block universes and they're relative. So how can an item in a future block universe affect a current block universe? Is it retrocausality? What is it? And the answer is we don't actually have to use time in the first place. Retrocausality meaning the future affects the past, which is there's a lot of in quantum mechanics. But what I'm saying here is we don't actually have to assert that. Because given with the extrusion principle, we're trying to kind of distance ourselves from the flow of time making causal things, why don't we even say, so now we're going to try to, why don't we even say, let's try some things out. Okay, so now what we're going to do is we're going to create implication arguments between two ethi along the direction in the block. So, along the Markov chain, you could say. One's a parent ethos, one's a child ethos. So one idea we could say is every child of an invalid ethos must also be invalid. Now this is kind of obvious in a sense, because how can you get, right, if the first one is invalid, then you can't get to the second one because you have to pass through the first one first. So you're going to, in other words, you're also going to inherit the invalidity from the first one in the form of the attributes. So we know that this has to hold. This is going to be our guideline. So what we're going to say is we're going to try to create a third postulate that doesn't contradict this statement. So it's almost like, yeah, like I said, it's our guideline. So here's an attempt at the third postulate, which we can immediately show is wrong because of this statement. We're saying, if there exists a child ethos to yours, which has a contradiction in it, then your ethos is invalid too. So if the child ethos to yours has a contradiction, that makes your ethos invalid. But we might say, here's why this contradicts this. You might say, well, this has an invalid ethos here, invalid child ethos here, why I put the slash through it. But this is clearly valid because by this condition, it doesn't have any means of proving it's invalid. So here we're saying that this one would be invalid, but that contradicts this one needing to be valid. Because if this is valid, and it's a child ethos of an invalid, so here we're saying every child of an invalid has to be invalid. So basically we're just like, these two clash like hell. Which maybe I didn't explain that well, I don't know, I can give it another go. Anybody see what I mean there? Which is, this is invalid, so if this is true, if every child of an invalid is invalid, sorry, if it has an invalid child, then that makes it invalid. This has an invalid child, so that would make it invalid. But this can't be invalid because it has to be a parent to a valid in order for this to be valid. Because if this was invalid, then this would be invalid. But we already know this can't be invalid. So if this is true, this is invalid because of this, but this has to be valid in order for this to be valid. I know it's very layered, yeah.
You can make a counterexample.
Yeah, it's a counter.
Just like a valid ethos and then just put an invalid statement on it.
Right, exactly, like this. And right, exactly. It's a counterexample to this if you assume this. That's a great point. Yeah, sorry, I might be getting tired. I'm not quite putting everything together in the exact right way. Yeah.
You know, it's just a nice counterexample to
Thank you.
retrocausality.
Yeah, right. So it's a good right, and even this principle, we know it's kind of wrong. There exist argument doesn't work. So we might try it for all, see if that works. It's also a bad idea because it's too strict. Because you could have a child ethos, where a future ethos, right? But future in the ethic direction, where you don't ever go to one of the people who went through the doors, like the friends who went through the doors. You don't ever go to one of them and ask them what door they went through. You could just decide not to ask somebody ever. In which case, you're not forming a contradiction because you never learn the information from them, which is needed to contradict your knowledge that they went through both doors based on there being a wavelength path. I might be talking too fast. I don't know. I feel like again, I told you this is the hard part, but yeah, that's the other pitch is we know from the empiricism, we know from the experiment itself that even intuitively, you could just refrain from asking them which door they went through. So we know that there have to exist child ethi, future ethi, right, where you don't go and make a contradiction. So if we say that for all child ethi you make a contradiction, well, we know that's already wrong because there could be some where you don't go and make a contradiction. So we just found ourselves in a bit of a pickle because we showed there exists and the for all are both wrong. What do we do? Anybody? Ready for this? This hit me. This hit me in a flash. I was like, oh my God, I got it. Ready for this? Use 2 generations. Right? Whoops. With this. A for all nested in a there exists. That's the key. Okay? And I'll explain to you why that works. It's right because it's just strong enough and just weak enough as a mathematical statement. It's wedged in between the two. And we can look back at this, for example. And the analogy was with chess. That's how it kind of came to me. I was like, oh, it's just like chess. So imagine you have an invalid child ethos, right? That's like what the situation A is in. If A goes down this branch in the ethic dimension, right, into possible future ethi, not time, goes down this branch, it's going to hit an invalid child ethos. So, like even intuitively speaking, A had better go down this branch in order to stay in good shape. Because even having the possibility to go down the other branch is bad news for you. So we could say A is in check to draw the analogy with chess. A is in check because it has a possible future where the king gets killed, aka invalid ethos. So what do? We move A out of check. You have to in chess. You have to move it out of check. Now we're in a good situation because B is not in check. They're valid. Child ethi are valid. So, okay. So in other words, we force additional attributes into A so as to move it to B to move it out of check. Now we don't have a possible invalid. So this, having a possible invalid ethis child is the same as that first condition, where the there exists. So in other words, we're getting rid of the first condition. If the first condition holds, you get rid of it by adding a new attribute. In other words, again, with the check analogy, you add an attribute to get rid of the possibility of hitting the invalidity. But then we might ask ourselves, what if every single move you can make, every single attribute you add in, you never get out of check? What if every time you add a new attribute, you still have an invalid child ethis that could be hit, even if you don't? And this is exactly what's happening with the soccer field double slit experiment, which is you don't have to go to one of the friends and ask them which door they went through, but you could. And no matter which attribute you add to your ethis, you still could. You might even add the attribute to your ethis, oh, it's impossible for me to do it, but that's an ethic contradiction anyways, because it is possible. You can. It's like we've already put that in our system. So the idea is, it's not that there exists an invalid, there exists a child ethis which gives you a contradiction in the soccer field example. It's that every single child ethis you could possibly go to in the future, every single one of them has a further child ethis that could be invalid. So every single one of them is in check. Because every single one of them, you still have the choice to go pick up a contradiction. That's the pitch. It's checkmate. So, in other words, the third postulate tells you that checkmate means invalid. Every ethis which is in checkmate is an invalid ethis. That's the third postulate. And if you want to be in the positive, you could say, if an ethis is valid, then it can't be in checkmate. That's the idea. And that's a contrapositive. And that is the basic base. Yeah, so thank you for coming, by the way. Yeah, thank you. But yeah, so yeah, that is, and then yeah, then we could start to actually check off the double slit experiment cases. We have all the postulates we need now to explain why some get invalidated. In other words, you never go down those routes because they're valid. Yeah, so this is the full picture actually. How am I going to explain this? Yeah. So yeah, it gives you that derivation. The idea is also I start with detector off here. Okay, detector off is when you get the wavelength pattern, and I believe that is when you invalidate these two, right? Because it's detector off. That's just because they contradict the second postulate. Second postulate tells you everything that's blank needs to be in agreeing superposition, which is the elemental superposition. So yeah, if the slit, in this case, the slit that you went through is blank. So these have to be invalid because, of that. So that's kind of the easy case. In this case, when the detector is on, you have to do two steps. The first step is you say, okay, well, you might say, oh, it's blank in my ethis that which slit I went through, which slit the particle went through is blank. However, it's not really blank because, again, the part I told you about where you can deconstruct an attribute into multiple pieces where one is blank, one isn't, there's a very subtle not blank piece here, which is we know by the third postulate this has to be invalid. That technically means that the slit you went through is not blank because you know that it's blank so long as you don't have a case for it, and that's not a true blank, that's a partial blank. So, in other words, and I'll tell you why this is invalid in a second, but once we invalidate this, then you put the rest in agreeing superposition, and then you just select one of them at the end, right? And then so it's a two-stage thing. The first stage is the detector is on and it puts them in disagreeing superposition. But you only add it to your ethis once you go and physically pick up the attribute. That's when you add it to your ethis. So one of these two cases. So then you, for example, if you look where the particle landed, you say, oh, it went through this slit. Oh, it went through this slit. But the first layer is so long as the detector is running, it's in disagreeing superposition. And then that even gives you the avenue to go through and check one of them. Okay, so these go in agreeing superposition, which is a disagreeing superposition of the slit itself, but an agreeing superposition of the ethi because of that diagram I showed you, or where's the ladder, there's the two steps, right? There's this and not this, and this and not this. And then you put those in agreeing superposition. So yeah, That's the pitch. Okay, now all we got to do is show why this is invalid, which we can just use the third postulate in the same mechanism, which is if this were valid, then you could always check the detector to see that the particles didn't go through the tube. So it's not even that you do, but you always could. So there exists, no, there doesn't exist a child ethos for which all further child ethi are valid. So third postulate, second order. This is pretty exciting that I'm explaining this, by the way. It's been a while. I've had this bottle up. I want to explain the hell out of this. Well, here I am. But yeah. So yeah, this guy right here is invalid because the third postulate counts it off. And you have these guys are in agreeing superposition, or the slits themselves are in disagreeing superposition because it's a layer down. Second order, first order, yada, yada, yada. And that is a derivation of why this friggin' experiment goes like this. So yeah, if this is right, I don't know if you've ever seen, like, if you watch this on YouTube, like double slit experiment, it's like everyone's like the devs are messing with us. Like, why the hell did looking at it change it? So, if this is right, then it's like, now we're like, oh yes, well now we finally know what the dev's trick is, which is this madness. But it has an algorithm that you can trace out and follow with logic. That's the pitch, which, obviously is what I find fun about it. Yes, question?
Yeah, so like to summarize, like in our material, the universe is kind of a machine that works tirelessly to avoid contradictions.
Yeah, that's a great summary. I love that. Yeah, and it invalidates cases that make contradictions. So the universe works tirelessly. Contradictions is the special case of invalid ethos. That's my pick. So the universe works tirelessly to throw invalid ethi out the window. And using this, that's the paintbrush. Using this medium of which invalid ethi you throw out, and by which reasons you throw those out, you can construct the universe.
That's not completely insane.
It is utterly insane.
But it's not completely insane.
It's not. I know it's not
something
completely
I
insane.
would say today, honestly.
And that's the fun thing. There's a real derivation. It's conceptually insane because now we have to live in order to get to this. This is the pitch. In order to get here, we have to live with the fact that block universes are weird and their superpositions all over the place, in disagreeing superpositions. But hey, what superposition is superposition? But if we assume the extrusion principle, we get to this. So the idea is, oh crap, this is the only way we get to solve this, so we better throw that commonsensical idea out the window to get to this. But yeah, logically, you can back up the logic, it gets you here. But yeah, this is the pitch for what the hell the devs have been doing to us for all this time. So yeah, I don't know. Anyways, that's all I got. Thank you. Thank you very much. Yeah, sorry that was a lot, you guys. I was gauging. I was like, oh, is that going to be? It was a long presentation, but yeah, hopefully that's. Thank you. All right. And yeah, Peter, I'll even shut this sucker off. Was that recording the whole time? I hope so.
It was, yeah.
Yes. Thank you. Okay.